Good to be back. Weather-wise, guys. Meteorologist Evan Chigbera in Birmingham, joined by Wes Peary, the legend in Kansas City.
And not true. But thank you. I will take it. And the new slogan here, Evan, what is it?
Occasionally wise geoscience guys. So, we talk about how we're trying to learn all the time, and there's always something to be learned. And I feel like we're decently smart. We're into geosciences, but this podcast is about learning, and so I thought it went together. Plus, it rhymes. I'm big on the rhymes.
We do have degrees in geosciences technically because we have to talk about things other than the weather.
Yep.
For our jobs, like everyone expects us to know about earthquakes and fireballs and meteors and stars. So I think it's accurate.
Yeah, and honestly, like I enjoy talking about that stuff like just as much because I think there's big crossover and there's a big interest in that. So like I go to these schools and they ask about tsunamis. For whatever reason, kids like to talk about death and destruction. I don't know why, but they do. So we always talk about that. We'll talk about volcanoes. We'll talk about astronomy and that sort of thing. So always fun. And
And I get the question, why is the sky blue? And I'm like, well, kids, it's because Rayleigh scattering.
yeah, explain that one.
Who's Rayleigh?
Not Raleigh, not Riley. So our topics today start with that. 50 Shades of Blue. How many shades of blue are there in the sky and why does it change? We'll talk about the clarity as well. The shift in La Nina, El Nino, what the heck is that? And of course, who's hot, who's not. It's always enjoyable. I like doing that. What the heck is going on with temperatures in the country? So lots to get to. We'll get right into it with Wes and his formidable research on blue skies. And Wes, I will let you
deep.
take it away.
I dug real deep. I've done this one before, but it's always kind of fascinating just to kind of watch the sky change, which is like such a classic weatherman to say. It's just fascinating to watch the sky change.
Gotta watch it.
From the hues of blue. Well, the sky is blue because of something called Rayleigh scattering, and I'm pretty sure Rayleigh is some physicist or scientist from like, I don't know, the 1500s.
From Germany, from
like
Europe.
Yeah, probably Europe, because Americans didn't really do much in terms of like weather discovery and weather forecasting whenever it was first being figured out. And I guess we do stuff with severe weather, but Europe's still really good at forecasting the weather in general. And this process to get a blue sky is called scattering. Whenever I was first trying to learn this, I was like, scattering, doesn't that mean like it's gone? You don't see it? No, scattering essentially means like you're able to see that color, but the right amount of scattering. Like if it scatters it too much, then you don't see it. It's still kind of difficult to wrap your mind around. But essentially what's happening is the air molecules are taking in the sunlight. And the sunlight is white, which means it's comprised of all of the colors in the visible light spectrum. Roy G. Biv. Evan, what are they?
Red, orange, yellow, green, blue, indigo, and violet makes a rainbow.
No, is that a real song?
Yep, it's from my kid's show, Little Baby Bum. So in case I ever forget.
Roy G. Biv. Sometimes when I say Roy G. Biv on TV, I have to like think of each letter. I'm like, all right, because I'll like forget green half the time.
Yeah. People probably think, hey, Roy's my friend, and his last name, Roy G. Biv. We hung out last week. Lots of fun.
Roy G. Biv. So the sunlight is being absorbed by the molecules, and then it's scattering out the Biv. Mostly the B, though. So you're seeing the blue. But sometimes, and I don't know like what the conditions have to be, but sometimes like the blue gets scattered out too much, and then you start to see the purple. But I've never actually seen a purple sky before, so I don't know when like that happens. But
interesting that it makes sense. If red is the second, it scatters. That combination there, like you can see here, is a bit of a purple, and maybe you have to be at a certain latitude for that because I know the angle of the sun has a big role in this. I did a little explainer this week because somebody was asking about cloud color. And several things go into that. If the cloud is really low, it'll look a lot darker, whether it has rain or not. If it's kind of green or blue, it can probably have hail in there, and that's the sun hitting those hailstones. It can look brown at times if there's debris going up into a tornado. Of course, we got those vibrant, beautiful orange and pinks when the angle of the sun is different. It hits it, and the refraction from those droplets, in a very similar way to what you just described, gives a different color. So, very cool. Like, it seems like one of those things. Like when they asked about the clouds, I'm like, that's pretty simple. And then you think about it, you're like, well, you don't know the full process. Same with the sky's blue. It's like, well, I know, but I don't.
And the whole sun angle thing is important for the color of the sky as you go through the seasons. And think of it this way, like in the summertime, the sun is, let's say my fist is the sun, it's like directly overhead during the hottest part of the day, the middle of the day. In the wintertime, it's a little bit more like this. It's not quite directly overhead. And really, like, unless you're at the equator, the sun isn't truly directly overhead at all. But that's like the relative thinking we're going on here. So if the sun's rays are going like this and they're hitting my head, and my hair is let's say my hair is the atmosphere, there's not as much hair to go through to get to my scalp. Meanwhile, if your sunbeam is like this, you're passing through more of my hair like the horizontal plane. So my hair is the atmosphere, and the atmosphere is composed of a bunch of molecules, and those molecules are then scattering and somewhat changing the hue of blue. And so you will get more scattering during the cold season versus the warm season because of that angle change. And you will also get a more light blue or a lighter tint to it, the sky, during the warm season because there's generally more moisture in the atmosphere. It's still really cold up there where their cirrus clouds are. There's still ice crystals and everything like that, but there are more water molecules floating around in general.
Yeah, we talk about the atmosphere, and just because it's summertime does not mean the whole column is warm. There's an area called the planetary boundary layer, and that's the lowest part of the atmosphere that we look at, and that's going to be what we talk about because you go up to where airliners fly, and you can have temperatures well below freezing, but like you said, when that sunlight is coming directly through, it's having to cut through a thicker atmosphere, one that's got water in it. Warm air also holds more pollutants. So I took this to a night sky too because I've noticed when it is cold out, walk outside on a winter clear morning. Before the sun comes up, you could see more stars. It's a crisp look, and it's for the same reasons you just said. The cold air doesn't hold the water. You have sinking air, which helps with the clarity. And the cold air doesn't hold the pollutants in the atmosphere like warmer air does. You have a tendency to hold on to ozone, and that will make the night sky look a little bit more hazy. So you'll have a view like that on the right versus the left. And again, a lot of people might not think twice about it, but if you do and you go outside, you'll know now why it is, why we have that. But I think the sun angle is so cool, how it changes things so much, and how you can literally see the difference. If you ever walked outside in the summertime, you don't see your shadow as much. You go outside in the winter, and your shadow's like, 7 feet behind you because the sun angle is not directly overhead. It's also the reason why we're not as hot, less energy with it being at that lower angle.
I didn't know that cold air held less.
Yeah, so the cold air, it causes a lot of the pollutants don't stay suspended in the atmosphere because of the sinking air. They'll come to the surface, and our surface air quality won't be as good, but the air above it, through the atmospheric profile, will not have as many of those particulates and whatnot. So, interesting stuff. I think.
just thought like fire season happens during warm season because there could be thunderstorms, there could be lightning, like in general. And it's like, oh, okay, well, that makes sense. Like in the warm season, you'll see more smoke and everything. You have longer, sunnier days, more potent, like sun angle to get ozone to form. I didn't know that actually had something to do with the ability to hold in pollutants.
Yeah,
Fun fact.
so you think about it like this: the warm air column, it's going to rise. So when we have wildfires in the summer, that smoke goes up into the atmosphere. When we have them in the wintertime at night, the air quality is horrific because all that smoke that went up into the atmosphere sinks with that colder air and it gets trapped. And we sometimes have our air quality alerts on those cooler mornings because you have called an inversion where it's warmer above the surface than it is, right where we're breathing. So all that stuff sinks to the surface, and it can lead to some nonsense. But interesting the little details that go towards this.
Yeah, and that's also part of the reason. Not quite exactly what Evan said, but the same blue sky situation with the sun angle. That's why whenever sunrises and sunsets are reds and oranges and pinks, is because the sunlight is passing through more of the atmosphere. It's interacting with more of the molecules, and so there's more scattering going on. You're able to tap into more colors in the visible light spectrum during that period.
Also, one other little fun fact, people
Yeah.
sometimes will say, why does the moon look massive, the sun look massive when it's coming up? Same thing. Phenomena with the angle of the atmosphere, it can cause an enlarged look. The sun, I promise, does not change its size, nor does the moon. But because of its angle and right when it's coming over the horizon, it kind of gives that illusion that it is much bigger than it is. And pretty cool. I love the moonrise. That's awesome when it's full.
You know what's always confused me, and I do my best to actually not talk about this on TV because I don't know. I just haven't taken the time to learn it. Is that whenever the moon is first starting to rise, it's not in its phase, right? Like it hasn't hit its, let's say it's like a waxing crescent. When it's first starting to rise, it's not like covered up in a certain percentage until it gets further up in the sky. This happened to me like 2 weeks ago. I was like, that moon is not supposed to be full. That moon is supposed to be something else. And like 20, 30 minutes later, it did end up getting to that shape.
Huh. I did not know that. That is fascinating. That it's not fully in its phase there. I wouldn't have guessed that. Good trivia question. So, the other thing we're going to talk about today is have you ever heard of El Nino and La Nina? People hear this and they get kind of freaked out. I'll sometimes go talk at schools. I was at one today, and people are like, they think of El Nino as this big storm or this big entity. When we talk about El Nino, La Nina, okay, it is a weather pattern shift. It is one that is almost global. It has to do with sea surface temperatures in the eastern and central Pacific and pressure values that change due to those water temperatures. So, what the heck does that mean for us? Well, if we have a change in where the warm or cold temperatures are in the ocean, that's going to affect the air right above it. Think about it, makes sense. Warmer sea surface temperatures, the oceans tend to mirror our atmospheric or our wind patterns around the globe. And so if we change where the warmer water is, instead of it being right up near the coast of South America, it's out in the central Pacific, that's going to cause jet streams, air masses, and everything to shift. So when that happens, we get a different pattern over the U.S. And El Nino, this is a summary of it. Doesn't mean it's the answer key, but we're typically dry in the Tennessee and Ohio Valley. You look at the southern United States, it can be wet. There's something called the subtropical jet stream, and it can absolutely plague us in the springtime and late winter because it sets up called the Pineapple Express. And because of that change in water temperature, you have this seasonal jet stream that'll just carry tropical moisture into the southeast across the Gulf. And then, the polar jet stream is confined. It's further to the north. So you have a different atmospheric setup.
And I'm actually surprised this map has my region in like an area of trend, like a trend area, because half the time you get to those locations that are so far removed from water. I mean, like even North Dakota and South Dakota are so far removed from water. Half the time there's just so much stuff going on other than El Nino that it's just like there could be like a million reasons why the winter forecast is the way that it is. Like whenever I'm making my snowfall forecast of the winter, I'll go through like El Nino, La Nina, the strengths of it, and it's like, okay, what's the probability of it being this strength? And historically, when it's been this strength, what has been the snowfall? And it'll be like that crapshoot. Like, okay, well, some years we get 30 inches, other years we get 3 inches. It's like, okay, well,
And it's
18 inches.
so like razor thin because if you get a couple storm systems because the jet stream is in a certain spot, it can be a totally different story. You had a day where what you got was it 17 inches in the spring, late winter?
And was it like January? We had an ice storm and then 17 inches.
I remember the pictures and you being outside the station. And the other thing too, in whatever phase this is, it's called Enzo. You can be in the El Nino, La Nina, or neutral. There are levels to it. If it's stronger, there's a more potent effect. If it's weaker, like the La Nina we're coming out of, there's not as big of an influence. So it's not even an answer key like, oh, here, this is what's going to happen. It's just a suggestion that with a pattern shift, and if it's weak, that we could see this. A La Nina setup. It also controlled for the exact same reasons. And these are, by the way, called teleconnections. There are all sorts of them. And it's where something occurs on one part of the hemispheres. It can be in the Pacific. It can be up near the Aleutian Islands. It can be out in the Atlantic. And something that changes, whether it's a pressure feature, sea surface temperatures, it alters where the jet stream is and it changes our weather over the U.S. We'll call teleconnections because something happens in one place and it affects elsewhere. So a La Nina setup for us as we head into the winter a lot of times can mean colder air across the upper plains. You're kind of right in the middle, Wes. Have you noticed anything when there's a La Nina swing about Kansas City?
No, nothing that really stands out. But again, I haven't really dug into trying to make a winter forecast yet. We do a winter weather special where we have to do our own weather story and then a snowfall prediction. So I haven't quite delved into that yet. But this map kind of illustrates like the problem that we have. Is you see like you go to the southeast where Evan is at. There's hints of it being um, wetter and warmer. And then you drive like an hour south and it's drier. Okay, but at least like there's like areas of trend. You go up into my part of the country and there's no trend area there. Like we're too far removed from colder. We're not really in the warmer. We're like kind of in the wetter, but not very much. The El Nino, there's at least like a minor trend here of it being warm, but that doesn't really tell us anything about precipitation. Like it says dry and wet. It's okay. So we're warm. You can still get snow when it's warm.
This is all relative too. When it says warm, it's talking about above average or above from normal. So if your average high and low somewhere is 44 and 27, that could mean we're 48 and 32. It just means that we're above the normal for that period.
So it's a really big probabilities game. You're trying to glean probabilities based on what's happened in the past. And so I have no idea what I'm going to do for my winter forecast. I mean, I'm sure what I'll generally sit down and do is be like, all right, let's look and see the strength of what La Nina is going to be, right? Because it's forecast to be a La Nina.
Well, we're
As,
actually coming out. They're forecasting that we're coming out of La Nina. We're going to be neutral. Now
okay.
that doesn't mean specifically we're going to be there. It's just a prediction based off of the MMJ and some other data that's looked at to determine this. Is that we're swinging there. So this is a setup for a neutral scenario. So we were in a super weak La Nina as it is, but this is neutral. So this is neither El Nino or La Nina. This is kind of in between, which is kind of hard to explain, but that means that the conditions that lead to one or the other are basically not occurring. So I guess you can call it normal, or there's no crazy anomalies, difference
Yeah.
from normal. So take it for what you will. Warm and wet for the southeast. You're once again in no man's land, right there along the polar jet, um, and the Great Lakes, New England, pretty cold.
Yeah, that's very, I mean, relatively normal, yes. Like cold in the upper Midwest, Canada. No way. Warmer in the southeast, like warmer compared to relative from whenever. Can you go back to the other two phases? Okay, warmer across the southeast, What El Nino? Wet. So normal. So like the southeast has a normally cool winter and an El Nino,
Yeah, so
but
like
in
what
neutral and Nina it's warm.
we don't see a huge deviation in temperature. Again, we've had different types of weather. I remember 2019 was so warm, so warm. We set several records. I don't remember what phase we were in, but our pattern was such that that polar jet did not make it to us, meaning the cold fronts that are associated. So when you talk about the polar jet stream, on one side of it to the north, that's your polar air mass. That's really cold. On the other side, you have more of a kind of continental air mass that's still cool, but relative to that polar air to the north, it's not quite as cold. You look at the jet stream pattern for a La Nina, it gets further south. So we've had some pretty big snow events in a La Nina setup because the polar jet gets further south. And if there's enough moisture, we can sometimes get winter weather.
Okay, so now go back to neutral. So neutral, it's like warmer, wetter. Okay, yeah, there really isn't anything that seems like super anomalous. Again, me here, we're just like could be either or. Don't know WTF.
I think
Uh,
the big takeaway is that when you hear an El Nino or La Nina, it does not mean there's a massive storm coming. When you see these icons that other people post that makes it seem scary, it is just a pattern shift. And all we can do is observe what's happening. One thing I've noticed, Wes, we've had several periods going back to late August where there's been really strong troughing in the eastern U.S. We had a record low August 26th, we dipped down to 55. It beat a record from 1962. But we've also had periods where there's a big ridge over Texas, and it's what's kept you warmer. We've been on the troughing side, so that kind of lines up with this. We could use wetter because we are super dry right now, actually in a pretty bad drought. And based off this neutral setup, this is a look at the seasonal precip outlook. So not looking great for us because we're already dry. Um, so I would like this to not come to fruition. Please.
and then look at that. The Great Lakes is just. I mean, there must be some sort of. I guess that's that polar jet. I feel like you're getting up there in the Great Lakes, right? Above average precipitation. That means you're getting lake effect snow. Um, I mean, all over Michigan, all over the Great Lakes, everything there. Yeah, there's your polar jet coming right off the water. And to get lake effect snow, you need to have relatively warm lake temperatures and then the wind blowing across it, generally out of Canada, and that will put more snow on the coastal or the lake coast sides
Yep.
of those states there.
That could be a future topic too, is talking about how small of a change in our winds can mean the difference between 3 inches and 33 inches of snow. It's quite fascinating how the tiny deviations, can change it significantly. So once again, you look at this map here, and this is a percentage. So we're leaning below average for the southeast, not significantly, leaning above average with greater confidence, near Detroit, central Michigan. And again, this is just based off of patterns and historical things. This could be totally different. That's why seasonal outlook's got to be taken with a grain of salt. This kind of makes sense to me because of that ridge that's been over the southern plains in Texas. If that shifts just to the west because of that troughing, that polar jet being over the Great Lakes, this would make sense. Your ridge over the southwest, your trough over the Great Lakes region, and that could lead to above average temperatures for that part of the country. So lots to look out for, but does this mean we will or won't have snow? I don't know.
This makes it seem like your polar jet's like not going to get um,
Like it's
south of the Mason-Dixon line ever.
Yeah, and honestly, when you look at this map, obviously it's going to be cold at times, but this kind of indicates that maybe the best potential for something like this, your trough gets down to maybe, you know, maybe the Ohio Valley, Tennessee Valley, but could have something like that, and then your big old ridge here. You'd have your high, and then all of the weather systems have to go up and around, up and around, and that hurts the depth, meaning it can't get as far south because you got this little blocking high pressure feature here. So um, definitely a lot to watch, and we will certainly do just that as we
I
get.
was I was just looking back what we were last winter. You know, we had that Gulf Coast snow.
Yeah,
It was neutral.
how about that? And that's one of those anomalies. There's never been a scenario where we literally had 10 inches of snow. It's literally records. So just because we're in a certain phase doesn't mean that other weather can't happen. It just means that overall, the average, what we're looking at, is a certain way. So we'll follow up on this and we'll watch the patterns as we head into winter. Of course, we'll keep this going with updates and everything else. So we'll be able to track this and maybe learn something. For those who have already entered winter and those staying in summer, this is a look at hottest and coldest temperatures since October 1st.
I came across one of these tweets from the WPC, and it's like hottest, coolest temperatures of the day, and one of them was in California for both.
So were 5 different locations in California that were over 100. They were all between 100 and 102, so I just picked one of them. It's down there south of Death Valley, south of LA, and there must be some sort of geographic influence because once you get to Los Angeles, it's significantly cooler. You get to 100 degrees there. You're just south of Death Valley. So I'm guessing the topography there, it's very desert-like across southern Arizona, New Mexico. Something happening there that makes it so hot because they had several locations that were over 100 degrees.
I wonder if you're getting obviously desert, some sort of compressional heating going on
Could be
with the mountains.
the mountains that are there, the Sierra Nevada mountains that stretch up, and then of course it's a very dry air mass, so there's probably a lot in play from topography. As for where it stands on average, I typed in the average last date of each of these temperatures that they hit. Average last date for a California location was September 30th. For Arizona, October 7th. So we've exceeded all of these days. Weslaco, Texas, October 22nd is typically the last day that we have temperatures over 100, and it was 103 on the 11th. So you can have outliers. And on the flip side, how about 8 degrees in Minnesota?
Cold like Minnesota.
Minnesota, I couldn't do it. I don't know how you guys up there north of Oklahoma City handle this stuff.
I think in the upper Midwest, they drink a lot of alcohol. I think that's how they do it. Like, some of the states that have the most alcohol consumption are there, and I'm pretty sure it's the winter time while they're doing it all.
That is actually quite fascinating, and I don't know if there's a way to dive into that, but that's a case study for social sciences. Very very interesting there. I mean, they say the biggest fake thing or myth is that drinking alcohol actually keeps you warm. It makes you feel it, but doesn't it like constrict your blood vessels or something?
Yeah, we went to school in the South, but that doesn't mean there weren't cold games toward the end of the season. And yeah, the whiskey warmth is a
Whiskey
thing.
warmth, science to it. So, but if you have something you want us to talk about, we'll discuss anything. I've been interested to hear some of the viewer questions. I've been doing Evan Explains, and people have asked some good stuff. One of them was about this exactly. Why are some seasons, some winters, cold versus hot in Alabama, and the clouds, the sky? That's what we're here for, to teach, to learn ourselves, and sometimes the questions you guys ask when we're researching them. And I know I learned something from you, Wes, when you talked about the lightning, when you talked about the urban heat island and convection. I mean, we've learned, we've improved on stuff. So the weather wise guys always getting wiser.
We did not do a forecast competition for this week, and honestly, it's because Evan and I forgot where we said we were going to
Yes,
forecast for. It just came back to me. I think we may have said like Tokyo or Beijing, like something just like totally like no idea.
you know what? I remember you saying something, and I was thinking the first thing I thought was, how am I going to find the sensor data for that? Because that's what I always have trouble is finding the weather station, and I had to reach out to Wes last time and have him send me the one for Jamaica. Um, but we'll get back with that next week. It was pretty busy the last couple weeks. I don't think we've done one since what, the end of September?
It has been a few weeks. Evan and I lead busy lives outside of weather-wise, guys.
We certainly do. It's fun, but this is a highlight. So we appreciate everybody who's hung around. Leave a comment. If there's something you want to learn about, if there's something you don't like, it better not be who's hot, who's not, because I like that's a good segment. So
it's the hottest segment on the show.
Good one. And that's a good note to end on. Weather-wise, guys, Evan Chigbera, Wes Peary. Until next time.
Give him a thumbs up. Will you give him a thumbs up with me? Thank you. That's your thing.